Good morning! I'm Dr. Huang. Today, I'm going to teach you some very important skills to solve problems that include ideal gas law and chemical reactions. Before you start to look for a solution for a problem, it is extremely important to rewrite the important information. When I say the important information, I mean a balanced chemical equation if you have a chemical reaction in your problem. Numbers with units and what you are looking for. If you do have a chemical reaction in the problem, immediately write down the balanced chemical equation. Then put down the numbers with units and what you are looking for in appropriate places next to the balanced chemical equation. Let's read the problem from the beginning. Consider the combustion reaction. When you see the keyword reaction, there must be a chemical reaction in this problem. So, we need to put down a balanced chemical equation. In other words, we need to find out what are the reactants, what are the products, and balance the chemical equation. When we continue to read, we find out that liquid methanol and oxygen gas are the reactants. CO2 gas and water are the two products. This is the balanced chemical equation. If you don't know how to balance the equation, please watch my previous videos. After we write down the balanced chemical equation, we need to find all numbers with units and what we are looking for, and write them down in appropriate places next to the balanced chemical equation. Let's do it now. Consider the combustion reaction between 25.0 milliliter of liquid methanol. We write down 25.0 milliliter below methanol under the chemical equation, and 12.5 liter of oxygen gas measured at STP. We write down 12.5 liter below oxygen gas under the chemical equation. The products of the reaction are CO2 gas and water gas. Calculate the volume of liquid water formed if the reaction goes to completion and you condense the water vapor. The volume of liquid water is what we are looking for. I write down a question mark to indicate this is what we are looking for. The density of methanol is 0.850 gram per milliliter. I write down 0.850 gram per milliliter below methanol under the chemical equation. And the density of water is 1.00 gram per milliliter. I write down 1.00 gram per milliliter below water under the chemical equation. Another good habit is to assign an appropriate symbol to the number with the unit. If you assign an appropriate symbol to the number with the unit, it will be easier for us to decide what equation to use, because all equations contain symbols, not numbers. 25.0 milliliter is a volume, so we put down V equal to. This one is the density, we put down D equal to. This one is a volume, we put down V equal to. This one is also a density, so we put down D equal to. Now let's see what kind of calculation do we need in order to find a solution for this problem. We are provided volume and density of methanol, which is a reactant. We also know the volume of oxygen gas, which is another reactant. And we need to calculate the volume of water, which is a product. This is a limiting reactant calculation problem. But for a typical limiting reactant calculation problem, we need to know the moles of two or more reactants. but we don't know the moles of either one. Therefore, we need to find a way to convert what we are given to moles. Let's say this conversion is possible or not. We know the volume and density of methanol. If you recall the density formula, we can easily convert to the mass of methanol. And if you know the mass of methanol, we can use the molar mass to find out the moles of methanol. Then let's take a look at oxygen gas. We know the volume only, and we need to look for the moles of oxygen gas. There's no such a conversion between the volume and the moles without additional information. So we can guess there must be some information hidden in the problem. In other words, not explicitly given. Let's look for that information. When we read the problem again, we find STP. Remember, STP stands for standard temperature and pressure. From here, we can find out the pressure and temperature. For STP, the pressure equal to 1 atmospheric pressure, temperature equal to 273 Kelvin. If we know the volume, pressure, and temperature of a gas, we can use the ideal gas law to convert to moles of the gas. So this is also possible. And if we know the mole of 2 or more reactants, we can use different methods to find out which one is the limiting reactant. And if we find out which one is the limiting reactant, we can calculate the moles of products you can produce. And if we know the moles of water, we can convert to gram of water by using the molar mass of water. And if we know the gram, which is the mass of water, we know the density of water, we can use the density formula to find out the volume of water. Now we can see we turn a complex problem into detailed steps. Step 1, 2, 3, 4, 5, and 6.